Hello and welcome to our PowerPoint of Maths at Dunkirk. This is following on from a workshop that we did recently for parents. However, we understand that for work commitments or for whatever reason, not everybody could get there. And for those of you who did attend, we thought that you might like to be able to recap on the stuff that we covered. So we've published this video so that you can keep coming back to it whenever you want. What we're going to cover today is the vision of maths across school, what we want to achieve. We're going to look at maths mastery in particular. We're going to go in more depth into fluency, consider the scheme that we've bought of Power Maths, and we're going to look at how we can fill the gaps for those children who may have struggled that lesson, but then at the same time, how can we challenge those children who have really grasped the concept. We'll look at what maths looks like on a day-to-day basis in school, and then we'll discuss how you can help your child at home. So our vision predominantly is for children to be happy, confident and successful, and we want them to be positive. We want to support them in learning new concepts, but we also want to challenge them and push them further in their thinking and in their development. And above all, the way that we do this is by looking at all the current research and thinking about what is the best way to support our children at Dunkirk. Throughout this, we believe that Power Maths completely covers all of our school core values. So it has problem solving, it teaches the children to be responsible with their learning, it gives them areas of independence, it means that they have to be determined to be able to solve the problems and the reasoning questions that we're giving them. And they also have to be empathetic. A lot of the tasks involve teamwork, so it's about what can we achieve, not what can I achieve. So back in September, we decided to move towards a maths mastery approach. And this is something that a lot of schools are beginning to do because all the research out there shows that this is the best way to teach children how to become wonderful mathematicians, not just now, but in the future. A lot of the stuff that I'm going to talk about, whilst it creates successful mathematicians now, it is crucial for their development in maths in secondary, A-level and further on throughout their life. So the expectation is that all pupils will move through the lesson at the same pace. Those who get the concept of the lesson quickly will be challenged by broadening their understanding. However, those who are struggling will be given lots of chances for extra practice or gap teaching before moving on to the next stage. Now, a lot of the the people that have been quoted here, I will put links onto the website so that you can go and have a look at some of the NCTM, the Enrich, all of that stuff you can have a look at, because I think it's really worthwhile. If you want to get a better understanding, these websites have some fantastic resources and some wonderful research articles for you to have a look at if you wish. So mastery in a nutshell consists of different representations and structures and making connections between these, using mathematical thinking to make connections and develop chains of reasoning, fluency to ensure that you can strategically and efficiently solve problems, and a variation in procedural and conceptual methods. So I'm going to go into fluency a little bit more because fluency is the one area that we don't feel Power Maths covers very well. Fluency, for a lot of people, they may not have heard about this in maths. However, it basically means that a child needs to be flexible in their approach. So by this, I mean they don't always rely on, for example, the column addition method. They've got a lot of other approaches that they can use that might be more efficient than that method. It means that they are accurate. With some of the written methods, there are lots of opportunities for mistakes. However, if they are flexible in their approaches, they can choose a method that would lead them to a more accurate answer. And it also means that the children are efficient in their workloads. So they're not getting bogged down in way too many steps, which can prevent them from solving those really challenging reasoning questions and problem-solving questions. So as a basic example, it does rely on the quick recall of facts and procedures. However, this doesn't mean that we expect children to rote learn things. We mean that we want to give children the strategies to be able to solve questions quickly and accurately. We also want children to have the ability to recognise relationships. So if they know their number bonds to 10, they know an awful lot more. They just don't know it yet, and we need to give them that skill and confidence to be able to utilise what they know and apply it to other situations. A really good example on this one is 42 divided by 3. A lot of children might look at that and go, oh my goodness, I've got no idea. However, as soon as you partition the 42 into 30 and 12, it suddenly becomes an awful lot easier. So one of the things that we want to avoid is children using really drawn out long methods to solve quite simple sums. So as you can see here, a lot of the examples, for example, 16 take away 9, the child has had to exchange their 10 into 10 ones. So they've just ended up with the exact same question that they were trying to answer before. They haven't made it any easier. They haven't got any closer to solving the problem. However, they've already had to lay out that question, exchange, which offers opportunities for mistakes, and then they're still in the exact same situation. If you look at the 1,000 take away 7, you can see that the number of steps the child has had to get to 10 take away 7 is 3. There are so many opportunities for mistakes there. That means that the child may not be accurate in their answer if they go wrong at any one of those points. Now, we're not saying that children cannot use column addition and column subtraction. They absolutely have their place in maths. And for example, it's just the same as using your fingers. We encourage children to use their fingers to count on and count backwards. However, there are certain questions where it is more efficient for children to use alternative strategies. And that's what we have to teach them, to know at what point should they use column addition and subtraction, and at what point would it be better to, for example, use their number bonds. So therefore, we have decided to incorporate a daily 10 to 15 minute fluency session to improve children's fluency in maths. Children will be taught a specific strategy, and then they will be given that time to practice it in a variety of different ways. And they will be encouraged to apply it to what they know. And this is really important, because it's all right giving them a strategy of number bonds to 10. However, that strategy can be used for an infinite number of word problems. So we really need to coach them and train them on how to apply their knowledge. Some of the areas that your children will be covering are, for example, the additive facts. Now, I know that this says year 1 facts and year 2 facts. However, what we and a lot of other schools have found is that children across the board still struggle with these. And if they don't use it, they lose it. So we don't get too bogged down on the fact that this is what year 1 is supposed to know and what year 2 is supposed to know. We will constantly bring these in to questions, even all the way up to year 6. They may be in a different guise, they may be bigger numbers. However, the basic principles stay the same. So in a particular lesson, a teacher will focus on one of these strategies, for example, their number bonds to 10, and how they can utilise this strategy to help them solve a range of problems. Okay, so when we're talking about applying what they know, Again, using number bonds as an example, here you can see that 4 add 6 is 10, 10 is the same as 6 add 4. So if they know all of that, they also know a lot more. So you can begin to increase the size of the numbers. Going into 40 and 60 is 100. You can begin to look at decimals. And then you can also go into more complex numbers, looking at 20 take away 6 or 50 take away 14. And we would expect that when children are fluent in their number bonds to 10, they can do all of those things at an age-appropriate level. Now, partitioning numbers is something that we really encourage the children to do because this can save an awful lot of hassle. So rather than counting on adding 8, a child should be able to see that they can partition that 8 into a 4 and a 4 because they know that 6 and 4 is a 10, and then if they're adding on another 4, they will end up with 24. That is the kind of thing that we do on a day-to-day basis, but we need to coach our children in doing. Partitioning numbers is something that they find really quite tricky. They get quite fixed in the fact that that number is just that number. So we really encourage children to think about how many different ways they can partition that number and how that will help them with that particular sum. Now, automatic recall of multiplications is something that Times Tables Rockstars has been helping with massively. However, it's really important that we keep on top of it. And again, just like with all of the other strategies that we are learning, we need the children to be able to apply what they know. So 0 plus 0.6 times 10 is 6. So they know that 6 times 10 is 60. They also know all of these other facts. Now, understanding the meaning of the equivalent symbol is something that is crucial for our children if they're going to be successful mathematicians when they grow up. A lot of children are fixed on the fact that equals means the answer. So 1 plus 1 equals 2. 2 is the answer. So as soon as they get to one of these missing number problems, they get completely lost because they do not understand why they aren't being expected to just give an answer. So we talk a lot about the equals symbol being the same as. So one side of the equation is the same as the other side. And if you think of it like a pair of scales and that both of the sides have to balance, as soon as you consider that representation, that problem becomes an awful lot simpler to solve. Now, this is also important because a lot of our children will be used to seeing a mathematical equation as something plus something equals something. However, seeing it as something equals something adds something can again really confuse them. So we encourage children to really focus on manipulating their number sentences, playing around with them, seeing what different combinations they can come up with. This might seem like quite a trivial thing, when you're a year 2 child. However, this ability to see flexibility in number sentences is absolutely crucial for when they get to secondary school, A level, and they're beginning to do algebra. And for us, we're thinking about our children as successful mathematicians in the long term, not just now. So it's worth investing that extra time to ensure they're confident with that, to make sure that they're successful in the future. So on to Power Maths. This scheme then covers all of the other areas of mastery that I mentioned before. So we're looking at different representations and structures of the concept that they are learning. We're looking at a variety in the types of questions and examples used. We're looking at really developing that mathematical thinking. The children are constantly looking for patterns, relationships, having to reason about what they've done and make connections to previous learning. So, for example, knowing that addition and repeated addition, that connection can be made to multiplication. So it also means that we as practitioners have a much more detailed knowledge of the curriculum, which is vital for student success. This scheme has been created by some of the best mathematicians in the country, and the way that it's broken down into the small steps, the logical steps, really helps your child progress. And it gives us the ability to not have to think about what we're teaching, but to think about how we're going to teach it, how we can make sure that our lessons are successful for every single pupil. So each year group has its own colour set of books, and each child has its own practice question book, and we have textbooks, one between two. Now, the same characters are seen throughout the year groups. The children know these very well, and these characters introduce a range of different problems, and then they help the children to solve those problems. Now, one of the fundamental aspects of Power Maths is that all children, no matter what their age, use manipulatives. And this is a really big aspect of mastery. There's a tendency for some children to feel that manipulatives are babyish. However, they are vital in children understanding the concept of the lesson. But also, when we're asking them to do those greater depth questions to explain their reasoning and maybe explain to a partner, some children find it really hard to articulate what they know. They just know it. So using the manipulatives can really help them explain the processes that they've been through to answer those harder questions. Now, interestingly, there's been some research published that for children to be successful in learning a new concept, which is what we're getting the children to do every single day, they have to engage 5 areas of the brain. And one of those areas is the visual area. And a lot of people make the mistake in thinking that a picture or a written example is enough to trigger the visual area of the brain. Unfortunately, a lot of brain scans have shown that actually the only thing that will trigger that area is physical concrete objects. So the children getting the objects, partitioning tens and ones, using bead strings, creating number lines, using actual physical objects. And that is the only way that they are going to fully embed the concept that they are learning that lesson. So to support Power Maths in the classroom, we decided to create 8 classroom norms that when we walk into a classroom, every single class will have these norms established. It is imperative that every single child believes that they can achieve mathematics to the highest level. Gone are the days of grouping children into lower ability, middle ability, higher ability, and them all having a different worksheet to do. That is gone. If you walk into one of our classrooms now, you should not be able to tell where children are in their learning journey. You should be able to see every single child on the same path. We absolutely have the mantra that if you can't do it at the minute, if you're finding it a bit hard, a little bit of hard work and practice will make you successful. Something that we've tried to really embed in the children is that mistakes are incredibly valuable. Every Power Maths lesson begins with a discover, and that is the opportunity for children to begin to explore a concept where making those mistakes is a safe thing to do. They're encouraged to make mistakes, and then they're encouraged to explain to their partner why it went wrong. We also strongly believe that mathematics is about creativity, it's about problem solving, it's about fun and enjoyment. It's about making those connections between other things that we have learnt, and also making those connections to everyday situations. We believe that depth is far more important than speed. Children in our lessons are there to learn, not to fill out 20 examples of the same question. We aren't interested in performance and how many questions they can answer. What we're interested in is, have they understood the concept? Have they shown that they've understood the concept? As long as that's done, we don't need them to give us reams and reams of answers to questions that we already know after question 1 that they can answer. So basic lesson structure, we always do key skills before any Power Maths lesson starts. So this just gives the ability for children to revisit learning that they've done previously in the year. So the way that our lessons are structured, we do place value first, then we do addition and subtraction, then we do multiplication and division. However, even though place value runs through all other areas of maths, it's really important that children don't just see place value in September and then have to wait a whole of the year to reach place value again. So we have Fab 4 sessions where children will answer 4 questions based on previous learning. Something that they did a term ago, something that they did maybe a month ago, something that they did a week ago, and something that they did yesterday. And that really gives them a chance to embed all of those skills and the concepts that they're learning. Then once you get into the Power Maths lesson, like we discussed, each lesson begins with a discover, so the chance for children to work together to discuss a problem and to try and figure out how they're going to solve it. The children will then share what they have learned. The teacher will then teach the concept that is necessary for children to be successful in that lesson. The children will have a chance to practice that, but their practice will involve a number of different representations and structures and really get them to deepen their thinking. All children must then do a reflect, which gives them a chance to apply what they've learnt. And then challenge questions are given for those who require it. So if they finish before everybody else, they have a set of questions that they can go to really push their thinking. Then at some point in the day, some children will do it with their maths lessons, some children will do it at another point. There will be that dedicated 10 to 15 minute fluency session. So now I'm going to start talking about how we challenge those children who have been successful in the lesson. And our main aim is to really broaden the children's thinking and to showcase that they really fully understand the concept by answering a number of different questions. So the questions will look at, for example, did you or somebody else make a mistake today and what did you learn from it? What new vocabulary have you learned, and can you explain to somebody else what that means? How is multiplication similar or different to addition? What were the main mathematical ideas that you learnt? What questions do you still have? And if you don't have any, could you create your own question? Now, these are things that are actually incredibly challenging, and we've got some examples of work that children have done, and it really does showcase how the children have learnt. So this one in the middle is a year 2 child who has come up with their own statistics question. So 16 children are in a class. The teacher says that it's sports day, and she says that 5 children do a running race, 5 children do a hopping race. So how many children do the relay? Show this on a tally chart. Now, in that lesson, there was no question like that. So that child has independently come up with their own question, and that is an incredibly skillful thing to do, but it absolutely shows that they've understood the concept of tally charts, they've understood what they're for, they've understood the concept of that lesson, and that's our main aim. So gap teaching, we use something called Numicon, and it's got a lot of resources. It's a very structured program, and it gives children the opportunity to revisit the concepts that they've been learning, and just delve into it in smaller steps to make sure that they are successful before they move on to the next lesson. So in a classroom, you will absolutely see a maths working wall if you walk into your child's classroom. Now, these aren't pretty displays that once put up stay up there forever. These are fundamental teaching tools in a teacher's toolkit. They give children things that will help support them in their lesson. So if they're struggling with something, rather than asking a friend or coming to ask a grown-up, the very first place that they should go is to the working wall, where they should see a range of things that have explained the learning that has gone on. If then they're still struggling, they can go ask somebody else for help. However, the purpose of these walls is to really support children in their learning on a day-to-day basis. So finally, how can you help your child at home? The most important thing that we would stress is that we want to make maths fun. We don't believe in worksheets of answering the same question in different ways over and over, because it can really make children bored, tired, completely turned off maths. And we want children to view maths as a fun and exciting thing. The way that you can do this is, it doesn't matter what they're learning at school. If your child is learning multiplications at school, however, they're really interested in area, go with area. Whatever they're interested in, investigate it. Take your child's lead. The other way that you can make it fun and engaging is by using real life examples. So, for example, if you're in a supermarket, money absolutely is a wonderful real life example. Let your children total up how much the shopping is going to be. Give them a certain amount of money. How much change are they going to have? Let them pay for it. Let them check the change that they've got. Do they recognise the value of the coins? Has it been accurate? Was their calculation accurate? Or did they make a mistake? And if they made a mistake, where did they go wrong? And how could they learn from it for next time? You can also use a bit of imagination here. Say to the children that you're going to recarpet the whole house. How much carpet do you need? Set a challenge, set a fun challenge. And you'd be amazed at the amount of learning that you can get from something as simple as that. So we also have Times Tables Rockstars, which is really crucial in helping your child become fluent in their multiplications. And more importantly, it's really fun and the children absolutely love it. I've had a number of parents question me about the battles. The battles are something that happen sporadically. We don't want to have a battle every week because we don't want the children to get bored. We want it to be an exciting and an engaging thing. So we will always tweet about battles and when they are going to happen. However, it's really important that your child goes on Times Tables Rockstars regularly and keeps practicing, because like we said, if they don't use it, they will absolutely lose it. Okay. Now, I hope this has been useful. If you've got any further questions, please feel free to come and talk to your class teacher. From feedback that we received from the workshops, we know that a lot of parents are struggling with the vocabulary that their children are coming home with, things like bridging 10. So I'm going to create a set of tutorial videos to help with that vocabulary and to really explain what it is and how you can use it to help your child practice maths at home. However, if you've got any suggestions at all, please feel free to email me at rachel.yurkiv@dunkirk.nottingham.sch.uk or email the office and get them to forward the email to myself. Another way of giving those examples is to please tell your child's class teacher, and then they can pass the message on to me. Thank you very much.